All right, so we are recording. Let's go through these step by step then. So, I think I've got some answers. First question, back-to-back stem and leaf diagram, and the basic saying, decide whether there are any outliers. So people generally got it, right? There's potentially one outlier. You don't need your laptop, Aidan. What? It's on Teams. But I haven't sent an invite because he never responded and said he wanted one. It's a bit late now. He'll just have to have the video. Right, so there is potentially an outlier. So you've kind of said here, yeah? So what we're looking for, decide whether there are any outliers. And we're looking at it going, yeah, potentially the 100 is an outlier. You could say, explain your reasoning. It just doesn't fit with the rest of the data, right? So you're explaining that kind of thing. I've written a lot of, in pretty much everyone's, saying, is there any mathematical reasoning for that? Right, what is the mathematical reasoning for, is there an outlier? Cameron? Yeah, so remember we should do, this one especially, we're probably looking for, let's do the upper quartile plus 1.5 lots of the IQR, and let's determine whether, now that's something, that's kind of like the top end level. So when I mark this, I can mark this question all the way through from like you don't know what an outlier is, for ones and twos, you might make some comment that, you know, roughly suggests you do. There might be a yes, it fits, it doesn't fit the data to get 4s, 5s, that kind of thing. But if you want the 7s and 8s for a question like this, you would have to actually justify it by saying, so what is the interquartile range for males? Do you actually know? Yeah?
I don't know the full interquartile range, but I know the median.
What's the median?
The median for the males is 37.5 kilograms.
So how many are there? There's 30 males, so the middle value would be the 15th and 16th. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So actually the median is 31. Right? Is that right? So then we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 above, and we've got 14 below. Alright? So then what's the upper quartile? Alright? So we split that 14 in half, would be the 7th and 8th. So 1, 2, 3, 4, 5, 6, 7, 8. So I've got 40 and 38. So the upper quartile would be between 38 and 40 is 39. And then the lower quartile, 1, 2, 3, 4, 5, 6, 7, and 8 is 20. So the interquartile range is 19. So then we do 19 multiplied by 1.5 is 1.5 of 19. So add 9.5 on, so that's 28.5. So then we were looking for the upper quartile plus 28.5. So that's 39 plus 28.5 is 67.5. So any value above 67.5 is officially an outlier. So we could say 100 is definitely greater than 67.5. So that means this is an outlier. Yeah? So that's when I said the mathematical reason. So definitely plenty of credit for saying 100 kilograms is an outlier, it doesn't fit the data, it's well beyond the limit of everything else, that kind of stuff. But where I've said, have you got any mathematical reasoning? If you did that, that's all we need to say. Right? It definitely is considered an outlier. Do you want me to pause at that stage? No, you're done. Alright, let's move on. So I'm not going to write so much, but describe, right, the masses of the male and female wombats. That's it. So what could we say as a description? And I've highlighted on some of you difference between describe and compare. I do not want to see anything in this bit about how the males and females compare to each other. I just want a basic description and nothing that shouldn't, no opinions or anything. So a description of the male wombats. There.
Well, both are the data is not
I don't want a both. I've just said I don't want a description of the male so far.
The male wombats tend to be around 31 kilograms.
Okay, so you've got the median is 31. We could write the median is 31. That's a descriptive statistic, yeah? Cameron, you going to say something?
I can say something similar. Just the male weight seems to be the highest at 30 to 39, which is
So we could say there seems to be a peak at the 30 to 39 area. Yeah, that's a descriptive term we could use.
Most of them are in the 20 to 39.
You could argue that the majority of them are between 20 to 39. Yeah, there's something you could write. You could say the range of them are from 10 to 50 if we ignore the outlier. Yeah? These are all descriptions without making any kind of assumptions or comparisons. They're just descriptive stuff. Right? Then describe the female wombats. Say the minimum is 8. Not the minimum is smaller than the males. That comes in the next question. Just the minimum is 8. The maximum is 50. We could work out the median is
30.
Should we try again? So 1, 2, 3, 4, 5, 6, 7, and 8. Is that right?
Wait, no, it's
1,
30.
2, 3, 4, 5, 6, 7, 8. So that's 30. So it should be. So no, I was doing the lower quartile then, wasn't I? So it should be the 4th, 15th, and 16th. Sorry. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Right. So yeah, for the width of the female, the median is 30. It's a description. Maximum 50, minimum 8. Sorry. Highest again 30 to 39. All these things you could write, just little bullet points. Yeah? So some of you would have lost credit because you maybe put one thing down, not more than one thing. It's not a very good description. If I put the word limited on your work, it's because you just didn't write very much. There could be an awful lot more to be said. All right? So without me writing anything in that space, does that make sense what we could do as a description? Just purely, this is what I can see. All right? You could write things like, I'm perfectly happy, I think I saw it in 1, it's a unimodal distribution. Yeah, we could say it's compact, there's not much spread there. Yeah, those are other things that we could say, definitely. Get you those higher levels as well, to say things like it's unimodal, low spread, all that kind of thing. Any other statements or questions at that stage? Okay, so compare the masses of male and female. Now is when you need to say things like.
The males on average are heavier.
Oh, on average.
Well, no, the males, according to their medians,
Yeah.
are 1 kilogram heavier than the females.
Yeah, we could say the median is 1 kilogram heavier for the males than females. Yeah. Yeah.
Then both are good, that's one of those between 60 and 90 centimeters.
Okay, well, would you put it as there's something not happening, or would you rather say this is what is happening? So you could say, ignoring the outlier, the maximum for both is 50. So it looks like male and female wombats generally reach the same maximum. What about the minimum? Yeah?
The female wombats have a lower minimum.
Okay. We could say the female wombats have a lower minimum.
And then the male
Is it a significant lower?
No.
Because the lowest for the males is 10, the lowest for females is 8. I mean, that's not a huge difference. That could be age rather than, we don't know, I don't think.
The males have a higher one because they have.
Yeah, but if we ignore the outlier, Then they don't.
The outlier, then they have the same rate.
Yeah.
But
you
if they're
could
not
say, yeah,
ignoring
there is one male that's huge compared to all the others. Steph? Yep. So there are 1, 2, 3, 4, 5, 6 males. And 1, 2, 3, 4, 5 females above what he's talking about, the modal class there. You could say, I mean, that's fair enough to say. You don't have to be differences, by the way, when you compare. What's the same? Same maximum, same kind of distribution. Yeah. Both unimodal, both got a mean, both got their modal class in exactly the same one. Both got the same shape basically, isn't it? So now you're comparing. Yeah?
I just have a question about like unimodal.
Yeah?
Wouldn't that mean they have like there's a single mode?
Yeah?
But then there isn't because they're.
Well, there is if we say modal class rather than modal value, because we've grouped it. You could say what is the mode, but we haven't been talking about the mode, have we? We've chosen not to at this stage. Yeah. This is a unimodal distribution rather than saying it's like there's one mode. Is that okay?
Unimodal, yeah, that makes sense.
Yeah. So we've got a single peak rather than two peaks. If I said about what is the mode, we haven't done that, but you could have done the mode is. All right. And what is the mode? So the female mode is 20.
Oh, 20, yeah.
And what's the male mode? 32, by the look of it. So that would suggest that the males is a lot higher, yeah? But you could argue that it's not relevant.
And 20.
And
20.
And 20. There you go. 20 and 32. So you could say that. You could argue that potentially the males are bigger because of the mode, but we wouldn't based on that. Right? So they're all the kind of things you can talk about there. All right. For those of you that just did a little bit, I didn't really know what to write, or I've not really ticked or done anything. Do you understand what should have been there? How you can improve that next time round? Yeah. All right, box and whisker plot. Nice and easy one, right? So, write down the median value. 80. Okay. Says the range is 20. Sorry, interquartile range is 20. The range is 40. So, A to 30 needs to be 20. So A needs to be 10. And from 4 to B needs to be 40, therefore it needs to be 44. Okay? So there are your answers for A and B. 10 and 44. I've written that very well. Alright, all good? This one was surprising how many people it caught out. 160 people were surveyed. Find the number of people who were 30 or older. So 30 or older is this part represented by 25% of your data. Yeah, we did that. If I'm told that the total was 160, I've got to work out 25% of 160, which is 40. Caught out a lot of people actually. No question. Yeah, you're not the only one. Makes sense, guys? That's kind of one of those questions that really is super easy, but if your brain's not quite switched on, because you might look at that and go, how am I supposed to know? You know? Because these numbers here, right, the 4, the 10, the 80, they're the number of years, they're not the number of people. So there is only certain numbers that that question can ask you. It could say, how many people are 30 or older, 30 or less? How many people are between 18 and 30? It could ask you that. 10 to 30. It could only ask you based on those numbers, and therefore your answers are only going to be 25% of it, 50% of it, 75% of it, or 100% of it. It can't be anything else. All right, for a question like that. Okay. Fisherman catches 200 halibuts. Just for the halibut. That joke. Just for the hell of it. Okay. Just me then. The table shows the lengths of these halibuts to the nearest centimetre. Calculate an estimate for the mean length of the halibut. So we should have done midpoint multiplied by frequency. So we should have 12.5 multiply 24, 17.5 multiplied by 38, 22.5 multiplied by 53, 27.5 multiplied by 39, 32.5 multiplied by 37, 10, 42.5 multiplied by 7. You work all those out. What do you then do? Add them together. Alright, and you get, and then we do question mark divided by total frequency, which is, add all those up, but we don't need to because it's 200. Divide by 200. And I don't know what the answer is, you can work it out now. Pardon? 24.2 cents. Okay. It says we've got to the nearest centimetre in the question, but it doesn't mean when we do a mean, we don't necessarily have to round our answer to the nearest centimetre either. So whatever all these answers are, add it all together, divide by 200, will give you the mean. Right? All good? Any questions? No? Do I need to pause? Are you writing them down? I will pause. Let's carry on then. Cumulative frequency. Now there was a big issue with the cumulative frequency. People just did not give evidence. Alright? Got to give evidence. So estimate the interquartile range. What am I expecting to see? Well, I'm expecting to see some lines on your diagram. Okay? I'm expecting to see, right? So if that's the maximum, right, you don't have to put this line yet, but if that's the maximum value, right, the interquartile range, so the median would be here, right? Sorry, not 100, at 100, so we need to figure out, so each square is, so 40 divided by 5 is 8. So each square is 8, yeah? So if we go 80, right, where's the, right, it's somewhere around 80, 88, 96, so it's about here then, yeah? Should be. So if I go across, that would be my median. But I don't want the median just yet, I want the interquartile range. So what's 200 split into 4? So that would be 50. So I've got 40 up to 50, so that's 48. Slightly above. So get across, read down, so whatever value that would be, and then 50, so I'm going to go to 250, so what would that be? Just that here, go across, there's a dot there, that probably helps, go down. Okay. So I am then looking at, what do we reckon this is? Each square is worth 1, isn't it? 16, 17, 18, so that's about 18. We say 18 or 19, up to 30. So then the interquartile range, all right, will be from 18 to 30, which is 12. You must put that. Now, some of you might say, oh, but you've not given me a mark or anything. Well, if I don't agree with your number, that's absolutely fine. So you see, I've had to kind of estimate, is it 18? Is it 19? Is it 18.5? I don't know. But what I've got on my graph is I've got the lines to show that I know where it's coming. Now, in fact, this line here for 30, it could be argued it's not quite straight, and, you know, but it's there. I have evidence of my thinking and reasoning. So for this question, because it's actually so difficult to get those actual values, I need to see where those values have come from. And a lot of you just did not do that. All right? Maybe you did put your pencil along and read down, but I couldn't see it, right? Unless you actually draw it on. All right? So we've got 30. The fisherman returns any fish smaller than 20 to the river. All right? Calculate an estimate for the number of fish. Again, I would expect to see a line at 20 going up, reading across. What do I think that value is? 40, 48, 56. So we go for 56. Is that right? So we could then go, right, 20 or smaller, 56 is the answer. Now again, if your number is slightly different than that, all right, maybe, I don't know whether I did it on the paper and I got a different answer myself, I don't remember, I thought it was 64.
I got 62. Yeah, I got that one. Yeah, because
I don't think this is, yeah, it's definitely not 56, is it? I think I got 64. Yeah, it's higher than 56. So it made sense. Not 56. So I got 64, so I think as long as it was in region of that, I gave credit, even without lines. So I thought, well, I kind of can see. If yours wasn't anything like that, then... Yeah? Well, it's not 56, we just said. Shouldn't know, it's too far away from my 64. I think that was a reading the scale wrong. Yeah.
I got 62 now because I used the actual table and not
Yeah, but it says
use the
smaller than 20. So we need to use the graph. The table doesn't do the smaller. We are using the graph for all of these questions now. All right. I did notice a lot of people kind of went back to the table. All right. Because you will see, and it says calculate an estimate. Now, what is different in the table? It's and equal to 20. Yeah? Whereas the graph is saying all the points on the graph, we read it as less than that point. All right? So we should use the graph. It then says, there's follow-on credit for a lot of these. Fish greater than or equal to 20 but less than 28 are classified as small. Greater than 28 or longer, equal or longer than 28 are classified as large. Estimate the number of fish in each category. So we've got 20. Let's go to 28. So 28 is about here. All right. So if I go up there and read off, I get a value. What do I get? 128. It's difficult, I suppose.
I said
136. 140. 142 maybe, something like that. So that's 142. Come on, don't get slow. All right, but what we've then got to do is say small then, all right? Small is between 64 and 142. So we need to do 142, subtract the 64, and we get the answer, what do we get? We've got calculators with you. 88? Okay, again, it's not what I had when I was, it's different on the screen.
No, it's not 70 because.
Yeah, it's not 88, I remember.
70.
Alright, I think mine was more like 70 something. So that would be the number of small fish, and at least one person kind of just went straight to that and forgot to take away the ones that you return. So small is 78. I guess you would return, although return is the 64, and then the large is from 142 up to 200, isn't it? So 200 take 142 is 58. Again, my numbers, I think when I did it myself on the papers you've got was slightly different. So as long as your numbers kind of matched similar to mine, with a process being shown, I kind of gave you credit. But if your numbers didn't match and there were no lines to show anything, then, or no working to show anything, then I couldn't give you credit for that. All right. Any questions on that at the moment? Like I said, it's say again.
Yeah, it's like the same as C.
Yeah.
Because I was kind of stuck on the table, and I was like, oh yeah, if I use the table for this one, for
yeah.
Table, then I was like, oh yeah, then this is the table for this one as well. So mine is different.
Yeah, and I get you. It's like that's giving you the graph for a reason. That's trying, you know. All right, and then. Says the fisherman sells, well, this one's super easy, isn't it? Whatever numbers you've got, you just had to multiply by 6 and 10. So I just kind of gave everyone the marks because at least you managed to do that. Whatever numbers you had, as long as you showed me you did it. All right. Any questions? Any comments? What you've got or not got? And then. Looks like I forgot to format this one, but this one was also interesting. State the modal class. This is the highest one, yeah? Remember, one of the last things we said in the lesson before was when we've got a histogram, do you remember we looked up in the book, we said, do we go for the highest frequency or do we go for the highest frequency density? And we looked up and went, definitely frequency density. So highest, we say is the modal class because the group's different sizes. Right, calculate an estimate for the mean waiting time. This was kind of a long, and again, a bit of leeway in your numbers because it's difficult, yeah? So, how do we work out a mean? Well, we need to figure out all the frequencies, right? So, how do we work out frequencies? Well, the frequencies are the areas. So, this one, for the first one, we've got a base of 40. So 40 multiplied by, well, what do you give that as? Yeah, 0.25. I actually personally did 0.2. Yeah, I don't care if you put 0.25. I'm happy enough with that as long as you put something. Give something, right? The next one is a difference of 20 multiplied by, well, that's definitely 0.5. The next one is a class interval of 10 multiplied by definitely 1.5. Then we've got a class interval of 20 again, is it? multiplied by 1 class input. Well, this now is at 60, 80, that's 90 to 120. So that's actually 30 multiplied by, could be 0.75. Yeah, I accept that. If that's 0.2, I actually went with 0.7. It probably makes more sense if it's in quarters, doesn't it? But I don't know. I just didn't. I went. It doesn't look quite like that one is higher than that one. All right. So the next one is from 120 to 180 is 60 multiplied by. So I've gone with 0.3, which is why I didn't think that was 0.25. And then finally, I've gone with, well, if that was 0.2, this one will be 0.1. And the class interval is 180 up to 240, so that's another 60. So that's all my frequencies, yeah? So let's work them out. So that is 8, 10, 15, 20, 21. Feel free to jump in. 60 multiplied by 0.3. 18 and 6. Again, as long as you're consistent. Now what do we have to do? This is a long question.
Add them all up.
No, is that, well, yes we could. We add them all up, but that's not, we've got to find the estimate for the mean. So we've got that many, but we now need to do what with that information? So the mean is, we've got 8 lots of the midpoint of the group. So 8 lots of 20. We've got 10 lots of, the middle of this group is, so that's 40 to 60, so the middle is 50. So this is the midpoint, yeah? And this is the frequency that we've just worked out. Is that making sense? All right. And then, yeah, we have to add all these up. So what's my total frequency? The sum of the frequencies. So what do we get? 18, 33, 53, 74.
That's
92. Again, I had a different answer the first time. I got to 101. I'm kind of presuming they're intending it to be 100, but it doesn't matter. As long as it's consistent. So whatever you work all these out to be, so midpoint, so I've got, the next one would be 15 multiplied by the mid group here, so that's 60 to 70, so that would be 65. So all of those results added together and divided by 98, we get the answer, roughly, what did we get? Anyone, nothing? No one got our final answer for this? No? No, tough one. Well, I'm not going to tell you the answer so you can work through this yourself. That's the mean waiting time. Find the total number of customers. Already 98, we think. Should be consistent with what you've done. Find an estimate for the number of customers who had to wait between 60 and 90. Well, that's between 60 and 90, so that would be your frequencies added up. Longer than 2 minutes is from 120 up, yeah? So adding those two together. Frequencies. All right. Now, what I'd be interested in is maybe you can do a bit of research in the textbook. Is there a quicker, more efficient, effective way to do it than I've just done? Using frequency density. I don't know, maybe it's something to have a look at. All right. But maybe for this now, why don't you have a go at finishing this off and see whether you can get that calculation done this way first. Yeah, let's finish it off. Any other questions at the moment about No?